All right, good afternoon, everyone. We are in weeks 2 and 3. I'm going to talk about functions today. We'll see if we can get through both of the PowerPoints, so we can just do exercises all week next week. We'll see. We may not be able to. Um, uh, Now we can start doing something somewhat practical with C. I know up until this point, we can do very basic things. We should at least be able to print things and make variables. But as the semester goes on, hopefully it will become more fun for you as you're able to do more and more things with your programs in C. So this week, I've got the PowerPoint pulled up. We're going to talk about functions, or rather in this module for the next 2 weeks, we're going to talk about functions. And I have it split up into 2 separate lectures. So let me tell you why I do that. There are 2 sides of interacting with functions in C. One side is use them. How do I use a function? And we've already kind of been doing that. So print F, for example, that's a function that you have to use. On Monday, all of those math functions that we used in class, those are all examples of functions. And you kind of saw how I used them. I had to pass them some information. Sometimes functions give you things back and you can save that information. So that's one side of functions. How do I use them? If someone else made the function, or if I make the function, how do I use it? The other side is, what if I want to make my own functions? I want to define my own named set of instructions, right? And the way we interface with those is slightly different. So I separated into 2 different lectures so that hopefully to make that distinction more clear. So let's start with the basics. In this lecture, we're really just going to talk about how to use functions and how they work. Let's start with our very simple definition, right? So a very simple definition for a function could be 1 or more statements that comprise one task that can be stored and executed at a later time. So we previously said in the very first lecture, well, you can think about a function like a named set of instructions. Well, typically that set of instructions represents one specific task. Here's one thing I want to do, and I'm going to have to execute a couple of instructions to achieve that one thing, right? And then, of course, I'd like to be able to save it. This is the important thing, is that I can save that, and later, if I want to repeat that task, I just call my function again, and it can just repeat those tasks again. There's a little more to it than that, but that's a very simple definition. And before we talk about using functions, let's go over the different pieces of a function. So every function is comprised of 4 different sections. We only need to know about 3 of them to use a function. So this first section here in red, that represents the data type of the value that the function returns when it's finished executing all those instructions. So some functions don't return anything, some functions do. If they do return something, that's what this field is. Now, when you're using a function, you don't see this. This isn't something that you see. This is something you just have to be aware of, whether or not it returns something and what that data type is, because that determines if you want to use that value, or if you want to save that value. That determines what type of variable you need, or how you can use that value. So this is the first piece of a function that you have to be aware of when you're using functions. The second piece in black here, the name of the function. This is what you type in when you want to use it, right? So we mentioned that functions at the very beginning. What are functions? Is a collection of statements, a named set of instructions that you can run again. Well, this is the name. This is what you type in when you want to run that set of instructions. And finally, parameters or input arguments. That's another term for these things. And what we see here in between the parentheses, so first of all, the parentheses are always required. They are never optional. And when you use functions, they may have 0 or more parameters. So some functions may not have any parameters. Some functions may have multiple. If they do have multiple parameters, it's just going to be a comma separated list of values, right? And this part here, the purpose of this piece is to give the function information that it needs to be able to execute the instructions appropriately. So let's take an example. Let's say a very simple function that is supposed to add two numbers together and give you back a result. So if you wanted to write a function that was capable of adding any two numbers together and returning the result, what information would you need from whoever wants to use that function? My goal in my set of instructions is to be able to take two values and add them together and then return a result. But I want to take any two values. Yes. I need to know those two values. Exactly. So that's what this is for. If I want to write a function that's capable of adding any two values together and returning the result, well, you need to tell me what those two values are. And that's what this is for. This is so you can provide that information to the function so it can use that information to return a result to you. Very good. And we'll skip this section here. Well, there's another section here that we'll talk about in the next lecture, but we don't need to know about this to use the function. These are the instructions. To use the function, you really only need to be aware that it returns something, if it does, and what the data type is. You need to know what it's called so you can use it, and you need to know whether or not it requires you to give it any information. And that's, you would do that in the form of this parameter list here, one comma separated list of values. So here are some examples of functions that we have seen already. We've used some of these. So printf. Printf is a function. Believe it or not, printf actually does return something. It returns an integer, it's a whole number, that represents how many characters it printed. Now, we haven't used that. We typically don't use it, but let's say you wanted to ensure that this behaved correctly, perhaps you could save that. And as long as it printed more than 0 characters, you know everything is good, right? But if you attempted to print something and later you look at that variable or you test it in your code and that variable is 0, well, that's no good. Something went wrong. For some reason, it didn't print what I wanted it to print. And the parameter here, we're provided in the form of a string. The only required parameter for printf is a string. So printf is a unique function. It has a variable number of parameters. You can give it one or more parameters. The only required one is the string, and the string represents what you want to print. So what do you want to print? You have to at least tell me that. The rest of them are optional. So we've seen examples when we had format specifiers, right? Where maybe I wanted to print some variable values. So if you have format specifiers in your string, then the other information you have to give the function is what you want me to substitute for this format specifier and that one and that one. Scanf, we looked at that one, right? So again, now this one has at least two required parameters, could have more. So the string and this string should just be your format specifier, or if you have more than one, plural format specifiers. And then for every format specifier you provide, you have to give it a variable to put that information into, right? So remember what scanf, why do you do that to me? And then my screen is black. I'm sorry. I don't even know how to turn this back on. Why is my screen black? Audio, video. This is power or something. Oh, okay, I got a picture. All right, let's be careful. Sorry, my for online students, I apologize. I lost the projector again, and I also lost the screen that controls the projector. So it's no bueno. There's a number somewhere that I can call for help. Okay, I almost got it back. Come on. Come on, baby. Oh, there we go. All right. Be careful. Okay, the projector is coming back out again. Okay, so we can see these two examples, right? If we go back to the previous slide and substitute this with printf, we know now that this is an integer. Printf returns an int. If we want to, we can save what it returns. We would type printf, and then here we would provide at least one string, potentially more, right? We've used it before, so we kind of know how it works. Same thing for scanf. Main is a special function. Main is a function, but it is also a function you should never call. So this is the one function you should never call. How do you call a function? When I say call a function, I just mean execute it, tell it to run. So when we type, for example, for example, oh, we'll get this out while we're going through this so we can give examples as we go. So for example, we'll just start something simple. Hello. All right, so I'm calling this function by, when I say calling the function, I mean typing in the name, giving it a parameter so that the function will execute. That's all I mean by calling a function. So you'll hear me use those two words interchangeably this semester. So I don't mean to confuse you. If I say execute it or if I call it, this is what I mean. I mean to use it in your program. We can see here, let's just do int printed just to see how many words are printed. And if we wanted to print that, printf printed, right, we can compile this and run it and we can see, I guess I should have done this. We can see that we printed 6 characters, right? We printed these 5 characters. We printed these 5 characters and we printed the return key. Right, so we can see that this does return something. If you want to, you can use it, but you don't have to. As in line 6, we didn't even save it, right? Main is a special function. You should never call it / execute it. So again, you should never do that. You can do that. It's not good. So it will keep calling itself over and over and over and over again, which is no bueno. So remember, this is the only function that the computer will, this is the, oh, so I haven't said, I shouldn't say remember. So your C program, your executable file is really just a collection of functions, a set of instructions that should be executed. When you launch your program, the computer needs to know which function should I execute first. What's the first function you want me to execute? It's always going to be main. So every C program has to have a main, or there's nothing to start. The computer has to know where to start. So that's what this does. The main function, having one of these, when you launch the executable, it says, oh, this is the first function I call, and the computer calls this one for you. You should not do it. That being said, you must have one if you want your program to run, and you cannot have more than one. Right, so the purpose of this function is so that the computer knows the first instruction it should execute. If you have 2 of these, which one should it execute? I don't know anymore. There's 2 of them now. I don't know which one to pick. Right, so you should only have one. You should never call it, and you have to have one if you want your program to actually run. So anyway, it's a special function. We'll talk more about that later, but main is a special function. PAL, we use this one on Monday, right? So PAL is a function that exists in the math library. And if you give it two values, of course, this function takes some value and raises it to some other power. So like the example we gave earlier, if you want a function that's able to do that, what do I need from you? Well, I need to know the number you want me to raise to some power, and I need to know the power you want to raise it to. So that's what these are for. And you would provide it two values. You give it some number and some power. For example, 2 and 8. And it does return something that you can save if you want to. So how do we use a basic function? We've already seen some examples. So point number one, when you're calling a function, even if it does not require any parameters, there are functions that don't require any information to execute. You still need the parentheses. So at the most basic level of calling a function, you at least have to type in the name and parentheses and a semicolon. So that's the most basic requirement for calling a function or using one. Type in the name, type in the parentheses because there's no required parameters. It doesn't need any information, and type in a semicolon. If a function requires information, if it has fields for parameters, you have to provide it every value that is required. So for example, the PAL function has two required fields. It requires two pieces of information. You have to give it those two pieces of information or it won't function correctly. Let's take a look at an example. Let's, well, this isn't going to work if I do that. I haven't worked that out yet. I can make it work. We'll do it here. Selection. Whoop, not that one. That's the executable file. All right, so let's take a look at this. Let's do include math.h. And let's try to call the PAL function and only provide it one value. So remember, the PAL function has two required parameters. You need to give it two things. It needs to know the number you want to raise to some power, and it needs to know what power you want to raise it to. If I don't provide it with both of those values, when actually we can't expect it to behave correctly, right? Because how does it? It can't. It's not going to guess the second value. But if let's try to compile this and see what happens. And you can see here, what do we get? We get an error message. Don't know if y'all can read that. Can y'all see that on the screen, or is the contrast weird? All right, so we can see here, right here, that we get an error message. And what does it say? Too few arguments to function PAL. So I only gave it one. I'm supposed to give it two. And it kind of told you that right here, even though that's probably not something we're familiar with looking at yet. So we can see right away, I didn't give it enough arguments. I need to give it more. It requires me to pass it 2. So let's go ahead and give it a second argument. We'll just do 8. And now it's happy, right? That goes away now. I gave it the second argument. That was the required argument. Now it's happy. So if you're using a function that includes parameters or arguments, you have to give it a value for each of the required arguments. And you can give it now, we gave it a literal value here, but again, it doesn't have to be a literal value, right? This could be a variable. And x equals 2. So if I wanted to, I could put an x right there. So I don't have to give it a hard-coded value. I could also recall that functions return something. So in C, even though a function is a set of instructions that you execute, Functions can return something. If a function returns something, as far as data goes, C views that as whatever its return type is. So this requires a double. So I could do that if I wanted to. Right. So, and this is the same thing. I'm still providing a value here. I'm giving it the number 2 because that's what's stored inside that variable. Here, I'm giving it the number 1 because 1 raised to the second power is still just 1. Right. This is the same as doing that. It's no different. C doesn't care how you give it the information, but you have to give it a value. Don't care how you give it to it, but it needs a value. Now, some functions return values. We've said that a couple of times already. If a function returns something, you can save it into a variable. Again, this, as far as C is concerned, if I'm expecting a value, C will interpret this as the whatever data type it returns. So in this example here, PAL returns a double. So as far as C is concerned, this is supposed to be a value. Well, it is. It's a double because eventually it's going to give you one, right? The other thing to keep in mind is that in C, functions can only return a single result. So there are other languages where functions can return more than one thing. They can return 3, 4, 5. They can return more than one thing. And C, that's not true. You can only give back one thing. So a function that does return something will only ever return one thing. And if we wanted to use that, well, we've seen an example already with the printf, right? If I wanted to save what this returns a double, value equals, right? We could just take this value because this will be a value when it's done executing and save it into the variable. Or we could use it directly, right? We saw an example of that the other day. I can just call 1, 4, right? So this is I have a format specifier in the string. So I'm telling C that I want to substitute something for this. Oops, I want to substitute something for this text right here. What am I going to substitute? I'm going to substitute the next thing in my comma separated list of parameters. And in this case, I'm going to call a function. It's going to return a value, and that's what I'm going to substitute for this. So if we compile this and run it, you know, it's happy with that. Any questions? Pretty straightforward, right? Using functions should be pretty simple, right? If a function requires parameters, give it values. If a function returns something, you can optionally save it or just use it immediately. It's up to you. Let's go over some things you can't. Let's go over some things you can't do with functions. So if I wanted to call this function, I know I need to give it 2 values, and I can give it variables. And here is something I see students do a lot, and this is wrong. And this is one thing that's different from creating a function. Okay, this is one reason I separate the two. I see students a lot do this. Now, before I tell you why you can't do that, can anyone tell me why you think I might not be able to provide this as the first value for the function? So think of, oh, go ahead. That's exactly what I'm trying to do. But what does the function want me to do? Exactly. The function wants a value. That's not a value. That's a variable declaration. In X doesn't mean anything until I give X a value. So this is one thing you cannot do when you're passing a parameter to a function. You should never declare variables when you're trying to use a function. When you're defining a function, and that's a different story, and we'll talk about that in just a moment. But when you're trying to use a function, you never declare variables here. And this is probably the biggest thing that I see students make a mistake on, is doing this right here when they're trying to use a function. Very good. All right, then let's see if we can at least start on the next one. So we've talked about using functions. What if we want to make our own? So right now, if someone else, like we know how to include libraries that are really collections of functions that someone else wrote, and we know how to use functions, right? We can use functions with parameters. We can use functions that return things. We can save those things if we want to. But what if we want to write our own function that someone else can use or that we can use later? Let's start here again. So now we're going to have to look at all four sections, all four pieces of a function. So remember the first part. This is the data type that gets returned when the function is done executing. In the previous lecture, if you're using a function, this part doesn't exist. It's blank. There's nothing there. You just have to be aware of the fact that that function returns something, and you have to know what that data type is. When you are defining a function, you're providing the definition. Here's what this function is. You're providing the definition for the function. It's your responsibility to fill that field in. You have to tell the computer what data type the function returns. So this could be an int, it could be a short, double, whatever data type your function will return when it's finished, that's what you have to put right there. Void, V-O-I-D, void is the data type that you return if your function doesn't return anything at all. So void means I don't return anything, right? So if you return anything except for void, you return something. If your function doesn't return anything, you just write the word void right here. This part is the same. It has to have a name. This part is different. So in the previous example, when you're using a function, you must provide values for these parameters. When you are defining the function, when you're creating it yourself, you do not provide values here. What you're really doing, you can look at this definition almost like a template or a blueprint. You know, here's a set of instructions. If I had values here, here's what I would do. And what belongs here are a list of variable declarations for all of the information your function needs to work correctly. So if we go back to the example, adding two numbers together, we said we needed two pieces of information, right? Two numbers. If I needed my function to be able to add two whole numbers together, I would provide two variable declarations, int number 1, comma, int number 2, right? And what I'm doing in my definition is I'm telling whoever's using this function, if you want to use this function, you have to give me two integers. That's what's required to use this. Right, so when you're writing the function yourself, this is a comma separated list of variable declarations, one for each piece of information you need. When you're using a function, this is a comma separated list of values, one for each piece of information that's required. Does that make sense? All right, and finally, we ignored this last time. When you're writing a function, this is required. Here's what your function does. These are all the statements that get executed when someone calls your function, right? And you must, kind of like the parentheses are required, you have to use these curly braces. These are required when you're defining functions. The open curly brace indicates that this is the beginning of my instructions, and the closing curling brace indicates that this is the end of my instructions. So everything in between are all the instructions that get executed when somebody calls your function. And you would just put your statements. This thing here in the square brackets, you don't include the square brackets. I included them to indicate that this is sometimes optional. If your function returns void, what does void mean? What do we say void meant? Void means no data type. If your function doesn't return anything, you don't write that word there. If your function does return anything, this is where you give that back. So for example, if your function returns an int, this is where you would return a whole number. You could return 1 or 10 or 20, or you could return a variable that was an integer. However you want to do it, this is where you would give that information back. Okay, so you would need to write the word return and immediately after the word return, what you're giving back. And it has to match that data type right there. So let's look at some examples. And we'll start kind of like we did the last one, from simplest to most complex. And it really isn't that bad. I know it's new for all of us, so it's going to be a little bit strange, but I promise you it's not that bad at all. In the simplest case, if you wanted to write a function that did not return anything and did not require any information, it would look something like this. You'd have the word void. So what do I return? Nothing. You'd have some function name, and then you'd have an empty set of parentheses. This means I don't require any information from the user. You'd have your brackets, and in between here, whatever instructions you want to execute. Doesn't matter. Your instructions go here. And notice we don't need a return statement because we don't give anything back, right? We indicated that by writing the word void here. And you should always have comments, right? So how would we do that? Well, I wanted to write a very simple function. Void simple function. I don't need any information. And what am I going to do? We'll just have one instruction. Oh, we'll have a couple. I am a simple function. So we just have two print statements in here. Those are the instructions we run. And let's compile it and try to run it and see what happens. All right, so I just compiled it. I'm going to run it. Hey, nothing happened. Why didn't it print anything? Let's look at the file again. Why didn't it print anything? I wrote my function here. There's my function definition. There's my two print statements. But when I ran the program, it did not print anything. What do you think? I never called my function. Very good. So remember, two different ways of interacting with the function. We're talking about two different things. Defining a function. All I'm doing here is saying that it exists. Here's a function. If you want to use it, here's how you use it. Here's your blueprint. But if I want to use that function, I have to call it. And where would I call it from? Where would I call it from? Inside the main. Why do I call it inside main? Why can't I call it from somewhere else? That's right. The program's going to call main first. So whatever I want to do, I don't have anything else in here yet. Main hasn't called anything else. So for now, if I want to call this function, I have to do it right here because my computer is going to call main. And once I get into main and I get to line 11, the computer is going to execute this instruction for me, which in turn is going to call my function and execute those instructions. So let's run it now and see what happens. And very good. Sure enough, it executed both of those print statements, right? So we can see defining a function here, right? What are the required pieces? I need to indicate what kind of information I return. I don't return anything. I need a name. I need to indicate whether or not I need information from the user, and I have to list my instructions. Here are my instructions. Defining a function, making one. Using a function, what do I need? Well, I need to call the function name, and I need to give the function any information it needs. Well, it doesn't need any information, right? We can look at the definition and we can see there are no parameters, so I don't have to provide it anything. What if I did this? Here's another mistake I sometimes see people make. So what do we think is going to happen if I do this and I try to compile it? I hit the plus sign, the two plus signs to build this. It's going to be okay. Why don't we try it and see? Let's not guess. Well, we got an error here, and if I guess it's hard to read, I'll read it to you. Error, the void value is not ignored as it ought to be. Right, so in our function definition, we stated that this was a void function. It didn't return anything. I should not be trying to save any return value because this function doesn't return anything, right? All right, next example. So that's a very simple function. If we wanted to make a function, didn't return anything, had no parameters. So let's look at the next level of complexity. What if we want to write a function that did need information from people? So let's take the add two numbers together. I want to write a function that's capable of, for now, just adding two numbers together. I don't want to give them back. I'm just going to add them together and print the result. Right? What do I need from the user? Well, now I need to provide some parameters. And what are they supposed to be? It should be a comma-separated list of variable declarations. And there should be one for each piece of information I need. So let's go back to our file. And let's write this second function. So void more complex function. Now I know I need two pieces of information. So we'll just say for now, I'll call this one num1 and num2. So I need to include two variable declarations here. Now in my function body, when I write my instructions, what we're going to do, we're going to use these variables as if they had values, even though they don't have values right now. But when someone uses the function, what are they going to do? They're going to give you this information, right? So when you're defining the function, when you're creating it, inside your function body in your instructions, you would use those variables as if they already had values. All right, and let's just print this. Actually, we could print all of it. So this is the first number, that's the second number, and this is the result. And we'll just do n1, n2, and result. And we know we need to call it, right? So let's call our function more complex function. And we'll do 1, 2, and 3. Is that what I should do? This look okay? Can I compile that? Why not? I'm printing 3 things right here. That's right, I don't need 3 things. I only need 2 pieces of information from the user. How do I know that? I know that because I only have 2 parameters defined here. So let's erase this last one. I don't need that one. What do I need from the user? I need the 2 numbers you want me to add together. So let's go ahead and compile this. And we can see, sure enough, it prints the first 2 things. It prints N1 and N2, the 2 things, the 2 pieces of information I passed to it. And it also printed the result of adding them together, right? That variable right there. So let's go over some common mistakes that I see students make. So here are some things I commonly see students do here. It's kind of the opposite of using a function, right? So remember when I said when you're using a function, what should you never do? You should never do that, right? Even if you're going to give it a value, you should not do that. You cannot declare variables when you're using functions. When you're using a function, what you should be doing is providing a value. And in turn, what's going to happen, this value is going to get saved into that variable. And this value is going to get saved into that variable. Here are some things I commonly see students do. Let's just copy this so I don't lose that. I commonly see students do things like this. Where they fill in the values right here. And that's not how this works, right? So again, when you're defining a function, it's not your job to provide these values. It's your job to provide a template that somebody else can use to, in this example, add two numbers together. Right, so if I were to do this, if it allowed me to do it, I don't think it'll allow me to do it, but if it would allow me to do it, then every time you called this function, what would the answer be? What would it print out every time I call this function, if it let me do this? Very good, because I gave it a value. So what is the point of this function? There's no purpose in this function. The only thing I can ever do is print out the number 42, because I statically set these things. It's never going to change. It doesn't matter what you type in here. As soon as I get here, I'm going to have a different value. The other thing I see students do, and I don't think it'll let me compile this anyway. We can try it. Yeah, so it doesn't let me do that anyway. It complains about that because we're not supposed to do that. So let's remove that. We know we're not supposed to do that. Here is the other thing I see students do that results in the same behavior I was describing if we were allowed to do that. Let's compile this. It will let me do that. And notice, oh, wait a minute. Oops. Oh, okay. I'm surprised it let me get away with that. It should not have let me get away with that. Let's do, let's change that. All right, so we'll call the second version of the function. As you can see here, even though I have, actually I can do this in JGrasp now because I'm not using the, so we can run this. Hey, what just happened here? Let's compile. Oh, and run it. And you can see I can provide any values I want for this. 3 and 5, which should print 8, should print 3, 5, 8. I can change this to 1 and 5, which should print 1, 5, and 6. But it doesn't matter what I put in here, it's always going to print the same thing, because in my blueprint, in my template, what did I do? Whatever value was in here, I immediately changed it to this. So here's the other thing I see students do a lot, and you have to be careful with this. So these parameters that you define here, these variable declarations, you should never assign them values inside your function. That is not how they behave. You use them as if they already had values. Never assign them values inside your function. Does that make sense to everyone? Okay. Slightly more complex. What if we had some parameters and we also return something? So final version, right? Let's say we actually did return something. Let's erase this because we know we shouldn't do that now. Oops, I erased the wrong one. Let's erase this because we know that's not right. And we'll make a int even more complex function. And now we are going to, let's do the same thing. Right, so I return something and I accept 2 parameters. So notice now we need this word. I need the word return. And what do I have to give back? I have to give back a number. It doesn't matter how I give it back. I could do it this way. I could do this, right? I could return a specific value, right? So I guess if we wanted a one-liner, we could just do that. Technically, we don't need this. But I have to give back an integer. I have to give back a whole number. Right? And using this, let's say, I call it even more complex function. Four and 5. And let's go ahead. We know we return something, so let's just save it. And we'll print it. So let's compile and save it. And we can see now what happens, right? We call, when we get right here, we're going to call that function. We're going to put the number 4 into that variable. We'll put the number 5 into that variable. And then I'm going to return that result. And I'm going to return 4 plus 5. All right, so we should never change these values. Remember, we should never change these values in here. We use them as if they had values. And I can use them any way they want. I don't have to do just that. I could do plus num1. So I could add them twice. I could do some other kind of math with those variables. The most important takeaway is that this variable will have a value inside it. And then I use it as I see fit. So for our purpose, our goal with this function is to be able to add two numbers together and return a result. So that's just how I'm going to use them. I'm going to use that value and add it to that value, and I'll just give back whatever the result is. All right, let's see. The return keyword. So this is a special keyword. I did mention that unless you're returning something, you don't need this keyword. It's optional. So we already know that one purpose of this word, right? So one purpose of the return keyword is to indicate that this is the value my function is giving back. That's one of the things it does. The other thing return does is terminate the function. So if I go back to this function, I can write all the instructions I want to after this. I'm not going to run. It doesn't matter how many instructions I write below that line. Notice we have this arrow here indicating that I'm exiting this set of instructions. So when I compile this and when I run it, you can see it never prints that. It doesn't care about anything below that line. So that's the other thing return does. It immediately exits a function. By the way, if you're using JGrasp and you want these lines, you just go into view and you check these boxes, auto generate control state diagram, and it'll make these every time you compile it, it'll make all this stuff for you. It's kind of neat. I can collapse sections if I want to and open them back up, and you get other indicators how the code's behaving, right? Now, I said you should never use it in a void function. You can, but you can't ever use it to return a value. If you wanted to use it in a void function, you just type in the word return and a semicolon, and it will behave exactly like I said. It'll exit the function. So if we compile this and run it, previously this printed the result. If I execute it now, you'll see it doesn't print the result. It doesn't execute this line because we exit before we get to that line. You may ask, what is the purpose of that? Why would you want to do that? Well, for now, we don't want to do that. We just want to understand it behaves that way. But sometimes, let's suppose you're writing some instructions and you only want to do these instructions under some certain condition. Maybe there's an error. You're doing some error checking. And if you gave me the wrong range of values, I don't want to execute this stuff. I'll just exit prematurely. So that would be one example of when you want you to use return to prematurely terminate a function. And I guess we'll cover this next week. Do you all have any questions for me? All right, then have a good weekend, everyone. Thank you.